Hello! In this presentation I will talk about how to analyze the discriminative properties of a classifier against a dichotomous or binary variable with SPSS. This procedure is called the ROC curve analysis. I will use the database called Adolescents Behavior 5, which is a downloadable resource of this course. Before performing the analysis in SPSS, I will briefly present the basic principles of the ROC curve analysis. The term ROC comes from a receiver operating characteristic. This is a procedure used in assessing the diagnostic properties of a classifier. It assesses the way various measures generally discriminate between different categories of subject. In order to do this, a cutoff point needs to be established. Based on the cutoff point, we can determine whether a person with a certain score belongs to one category or another. For example, in our database, adolescents with and without disciplinary violations. The dichotomous decision process is based on a cutoff point, which classifies the scores of a continuous variable, let's say the number of absences from school, also called a classifier, into two categories: positive, for example with disciplinary violations, versus negative, without disciplinary violations. Now, let's suppose that our established cutoff point is 30 absences. If the number of absences is equal or higher than 30, the adolescent will be classified as positive, which means with disciplinary violations. If the number of absences is lower than 30, the adolescent will be classified as negative. Now, besides the classifier, which is the number of absences, we have a valid procedure of discriminating between the presence and the absence of disciplinary violations, also called valid diagnosis. This is the school disciplinary record of the adolescents, which indicates objectively if they committed or not disciplinary violations in school. The confrontation between the valid diagnosis and the classifier generates four possible outcomes. If the valid diagnosis is positive and it is correctly classified as positive, the outcome is counted as a true positive. If the same outcome is incorrectly classified as negative, it is counted as a false negative. If the valid diagnosis is negative and it is correctly classified as negative, the outcome is counted as a true negative. If the same outcome is incorrectly classified as positive, it is counted as a false positive. The last important thing that we should mention is that from this confrontation, there are two important statistics that result. The first one is sensitivity, also called the true positive rate. It is defined as the probability that a test result will be positive when the disorder is present. The second one is specificity, also called the true negative rate, and it represents the probability that a test result will be negative when the disorder is not present. The sum of these two statistics represents the discriminative accuracy of a screening test or a classifier. Now, let's apply all this information. The objective of our analysis is to inspect the number of absences from school and the number of family members and find out how well they discriminate between adolescents with and without disciplinary violations. Also, we want to establish the optimal cutoff point for each of these two variables. So, let's begin. I will select Analyze, ROC curve, and as you can see, we have a window in which, on the left side, we have a list of all the variables from our database. On the right side, we have an area called Test Variable, where we have to introduce our classifiers. So in our case, we have to introduce the number of absences and the number of family members. The next area is called State Variable. Here we have to introduce the valid diagnosis, which in our case is the presence or absence of disciplinary violations. So I will introduce here disciplinary violations. As you can see, there is a new area that is activated called value of the state variable. In this area, we have to introduce the code for the presence of the state, which is the presence of disciplinary violations. In our case, the code is 1, because as you remember from the beginning of this course, we coded the presence of disciplinary violations with 1 and their absence with 0. Now, in the lower part of the window, we have an area called Display. Here we have the following options: rock curve, which will display the graph for our analysis, with diagonal reference line, which will display the curve of a random test, standard error and confidence interval for the area under the curves, and also coordinate points of the rock curve, which means the sensitivity and specificity for each possible cutoff point on the classifier variables. I will select all these options and I will click OK. And let's see the results. In the first table, we have a summary of all positive and negative results and also our missing data. Now, let's take a look at the graph. On the horizontal axis, we have 1 minus specificity. This is the opposite statistic for the specificity, also called the false positive rate. On the vertical axis, we have sensitivity, also called the true positive rate. The space generated by these two axes is called the rock space. Because each of these two axes is a probability, varying from 0 to 1, the total area of the rock space is 1 unit. Now, as you can see, in this space, for each of our classifier, number of absences and family members, we have a curve. How were these curves obtained? Let's take the number of absences as an example. This is the blue curve. For each possible cutoff point in the distribution of absences, there is a certain rate of true positives and a certain rate of false positives. This means that we can place a dot in this graph for each possible cutoff point. By uniting all these dots with lines, we obtained the rock curve corresponding to that classifier. Also, we can calculate the area under each curve, also called the area under the curve, AUC, and as you can observe, each curve can have an area between 0 and 1. As an area gets close to 1, it indicates a high discriminative accuracy between adolescents with and without disciplinary violations. Now, how about the reference line, which is the diagonal of this graph? This line is actually the rock curve corresponding to a random test. So, if we try to classify the presence or the absence of disciplinary violations by throwing a coin, this classifier will also generate a curve in the rock space. But because the coin generates a probability of 50% of correctly identifying the presence or the absence of disciplinary violations, the area for this classifier will be 0.5, which means half of the total area of the rock space. So, in order to have a significant classifier, its area under the curve should be significantly higher than 0.5, which is the area corresponding to the random classifier. Now, let's inspect the second table, which incorporates the area under the curve for each classifier. As you can see, the area for the number of family members is 0.92, while for the number of absences is 0.63. The same table contains the significance level for each area. As you can see, both are significant discriminators because their significance levels are lower than 0.05. But it seems that the number of family members have a higher discriminative accuracy. Finally, the last table from the results section incorporates the coordinates of each curve. This means that for each of our two classifiers, the table presents each possible cutoff point with its sensitivity or rate of true positives and 1 minus specificity or false positive rate. How can we find the optimal cutoff point? Remember that the optimal value is the value which generates the highest accuracy, or the highest sum of sensitivity and specificity. So first, we have to subtract each value from the last column from the value of 1, sum it up with the sensitivity, and find the cutoff value that generates that accuracy. I will perform the computation for the number of family members, and you will perform the computation at home for the number of absences. So, as you can see, for the value 4.5, which actually means 4 family members or higher, we have a sensitivity of 0.92 and the specificity of 0.80, which is 1 minus 0.19. And the sum will be 0.92 plus 0.80, which equals 1.72. This is the highest sum. You can verify this at home. So our optimal cutoff point is equal or higher than 4 family members. So briefly, these were the main procedures when performing a ROC curve analysis with SPSS. Don't forget to leave a rating and see you in the next presentation.
Take a step back to see the truth.